Here we have the definite integral of, with the function 4 minus the absolute value of x minus 2. And we want to evaluate this definite integral. And so again, this definite integral represents the area between the graph of the function 4 minus the absolute value of x minus 2 and the x-axis from 0 to 6. And so this is what the graph looks like. And so this is the graph for the function f of x equal to 4 minus the absolute value of x minus 2. And it's the absolute value, and therefore we need to break it up into two regions. So we break it up from 0, it looks like about 2 here. So we'll find the area of the region from 0 to 2, and then find the region from 2 to 6. And so whenever we have a function with absolute value, what we want to do is rewrite this using the definition of absolute value. And so by definition of absolute value, this function here, this is going to equal to 4 minus x minus 2. The same thing if x minus 2 is greater than or equal to 0. And this will be equal to 4 minus the opposite of the x minus 2. So it's equal to negative x minus 2 if x minus 2 is less than 0. And so it's the same thing if it's, if it's 4 minus the same thing of what's inside the absolute value, then that's when the if x minus 2 is greater than is positive, basically. And then 4 minus the opposite of what's inside the absolute value. So this is the same. So this is the same as what's inside the absolute value, and then this is the opposite of what's inside the absolute value. And so this becomes 4 minus x. So 4 minus, right here, this is minus x, and then minus 2. So it would be minus x plus 2. And then this becomes minus and minus. This will make it plus. So it would be plus and plus. And so we just get 4 plus x minus 2, plus x minus 2. And then here, the inequality, we add 2 to both sides, then we get x greater than or equal to 2. And then here, we add 2 to both sides, and we get x less than 2. So this becomes 6 minus x. And this becomes x plus 2. And then now we'll set this right here. Set this up with two separate integrals. So the first integral, the 6 minus x, this is for x greater than or equal to 2. And then the second integral is x plus 2 for x less than 2. And so let's go ahead and do the from left to right. So from here to here is 0 to 2. So this is, so we're going to go from 0 to 2. And 0 to 2 means x is less than 2. and therefore the integrand will be x plus 2, and then dx. And then, so this integral is for this shaded region right here. Okay. Let's put a line right here so we can see. And so this is 2 right here. And so this integral would represent this shaded region. And then the second integral would be from 2 to 6. And from 2 to 6 means x is greater than 2. So if x is greater than 2, then we'll use the 6 minus x for the integrand, and then dx. And then now we need to evaluate the two definite integrals separately. So let's do this one first. And then we'll do this one. And so for this one, the antiderivative of x plus 2, this is like x to the first, so the antiderivative be x squared over 2. And then the antiderivative of the constant 2, which is 2x. And again, by the fundamental theorem of calculus, this is f of 2, the antiderivative at 2, minus antiderivative at 0. And so we need the antiderivative at 2, and then we need the antiderivative at 0. And so here, in the place of x, we put 2. This is 4 divided by 2 is 2, and then this is 4, and so we get 6. And then right here, if we put 0, then we're going to get 0. And we just get 0. And so this becomes 6 minus 0, which is 6. And so this right here, this is 6, and then plus something. And now let's do this integral. And so here the antiderivative. And again, the fundamental theorem of calculus says that this is the antiderivative evaluated as 6 minus the antiderivative evaluated at 2. So the antiderivative of the constant 6 will be 6x, and then minus, this is x to the first, so add 1 to the exponent, and then divided by 2. And then we need f of 6 and f of 2. And so in the place of x, we have 6, 6. And then here in the place of x, we have 2, and we have 2. This is 36, and then this is 36 divided by 2, so it's 18. So 36 minus 18 will be 18. This is 4 divided by 2, which is 2, and this is 12, and therefore it would be 10. So it's 12 minus 2, which is 10, and therefore this will be 18 minus 10, which is 8. So the second integral is 8, and so together we get 14. and look back at the graph, then what it means, the first shaded region right here is 6, and then this shaded region is 8, and so together it's 14. And if we look at this shaded region right here, that's just a right triangle, and the base is 4, and the height is 4, so 4 times 4, which is 16, and then half of it is 8. And then this shaded region right here, that's the trapezoid. And so this trapezoid has an area of 6. So that's how we handle integrand with functions that has absolute value.